Hi friends, welcome back to Joe Educare.
In this video, I have explained the derivation on EMF equation of a transformer. Let's get into the video. Under this topic, we are going to find out the equation for EMF of a transformer. So equation is nothing but we are going to find out the formula for EMF of a transformer. So in a transformer, we know that two types of EMFs we are having. One is E1 and one more is E2. So we are going to find out the formula for E1 and E2. So to start with the derivation, so we know that induced EMF E is equal to minus N d phi by dt from the Faraday's law of electromagnetic induction. The first thing is I will find out the equation or a formula for E1. So induced EMF in the primary winding, I will take it as E suffix 1, which is equal to minus N will become number of turns in the primary winding is N1 d phi by dt. So this will be your first equation. You are going to write the induced EMF in the primary winding. In order to derive the equation, now we know that phi is nothing but alternating flux. So we know the equation for alternating voltage, which we have studied earlier in the previous chapter. E is equal to Em sin omega t. In the same way, for alternating flux, if I want to write an equation, so phi will be equal to phi m sin omega t. So this will be taken as equation number 2. Now I am going to substitute 2 in equation number 1. In the place of phi, I will substitute phi m sin omega t. So now this equation, I can write it as E1 is equal to minus N1 differentiation with respect to t. In the place of phi, I will substitute phi m sin omega t. Now I will simplify this. So E1 is equal to minus N1. So if I want to differentiate with respect to t, the term without t will be constant. So phi m will be constant. I will take it out. So I will get phi m constant. So differentiation of sin omega t you are going to do. So when you differentiate it, E1 is equal to minus N1 phi m. So differentiation of sin omega t, you know that it is plus cos omega t into omega. So now this omega term, I will write it here. I will get minus N1 omega phi m cos omega t. Now this negative sign, I will write it together with cos. So E1 is equal to omega N1 phi m. So negative, I will write it along with cos omega t. So now I am going to convert this minus cos omega t to sin. So we know that sin 90 minus theta is equal to cos theta. So in the place of theta, here you have omega t. So sin 90 minus omega t will be cos omega t. I need to convert minus cos omega t. So what I am going to do is I will multiply negative sign on both the sides. So now this minus, when I take it inside, you will get sin of minus of 90 minus omega t. So you know that sin of minus theta is nothing but minus sin theta. So in the same way, I am going to substitute this minus negative sign inside the bracket. So this will be equal to, on the right side you have minus cos omega t. So this I will simplify now. So sin of minus sign I will multiply inside the bracket. So minus into minus will be plus omega t. So I will write down plus term first, omega t minus 90, which is equal to minus cos omega t. So this will be the formula. So when I convert minus cos omega t, I will get sin of omega t minus 90. So this is what I am going to substitute here. So E1 is equal to omega N1 phi m. In the place of this, I will substitute sin, which I have got, sin of omega t minus 90. So this I will take it as equation number 3. Now I need to find out the equation for EMF, that is capital E1 and E2. So to find that, we know that E is equal to Em sin omega t. Now if I want to write the same equation for E1, E suffix 1, it will be equal to Em1 sin omega t. Just refer the general equation. So by referring this, I have written for E1, E suffix 1, it will be equal to Em1 sin omega t. So I am going to write down this general equation. E1 is equal to Em1 sin omega t. This I will take it as equation number 4. So just compare these two equations, the equation which we got earlier, which we have taken as equation number 3, and the equation which we have written just now, which was taken as equation number 4. I will compare equation 3 and 4. So when I compare these two equations, in the left side you can just see E1, both are equal. Okay. In the right side, sin omega t, here also you are having sin of some angle, omega t minus 90 or plus 90. Don't worry about that. Here one more thing, in the place of Em1, you are having omega n1 phi m. So this is what I'm going to equate. By equating these two equations, in the place of em1, you are getting as omega n1 phi m. Now omega is nothing but, you know that, 2 pi f. n1 I'll write as it is phi m. So this I'll take it as equation number 5. Now we need the equation for EMF of a transformer, that is for E1 and E2. So this was our target, to find out the formula for capital E1 and E2. In that, first we are going to find out for E1, that is capital E1, but we got the formula for E suffix M1. So this is nothing but maximum induced EMF or maximum voltage, which we have got the equation. Now I need to find E1. So we know that normally we used to write, instead of writing ERMS, we used to write only capital E. Is it right? So in the same way, can I write this ERMS1 as capital E1? See both the equations which are written. So this E1 is nothing but, I can say that it as ERMS1. I can say that E1 is nothing but ERMS1. So to find RMS value, you know that RMS value is equal to EM divided by root 2 for a sine wave. Now this is also a sine wave. Why? Because you got an equation in the form of sine. So this is also a sine wave. You know that ERMS is equal to EM divided by root 2. So if I want to write the same formula for ERMS1, which will be equal to EM1 divided by root 2. The formulas, everything are same. Only thing is we are going to write 1. If I write 2 also, this right side it will change. I can write EM2. That is the only change. But the base formula is this. So I'm getting that ERMS is equal to EM1 divided by root 2. That is nothing but RMS value is equal to maximum value divided by root 2. Okay. This will be your fifth equation. I'll draw a box for that. Now, if I want to find out E1, equation for E1, which is equal to ERMS1, which is equal to ERMS1 is nothing but what? EM1 divided by root 2. So EM1 divided by root 2. I'll just write down the formula which we have got here. So now, if I want to find out the formula for E1, which is equal to EM1 divided by root 2. EM1 is nothing but the equation number 5. That is what you are going to substitute here in the place of EM1. So the answer was 2 pi f n1 phi m divided by root 2. So this is what you will get. Now just simplify 2 pi divided by root 2. So when you simplify this, you will get as 4.44 f n1 phi m. So this will be the equation for EMF of a transformer in the primary winding. So the unit for EMF is volt. Now in the same way, I can also derive for EMF induced in the secondary winding, that is E2. If you derive in the same procedure, you will get the equation. You will end up with 4.44, same equation f. Instead of n1, if you are going to write for secondary induced EMF, n will become n2 phi m as it is. The unit for induced EMF is volts. So this is about the EMF equation of a transformer. Now at the end, after finding the formula for E1 and E2, just divide E2 divided by E1. So E2 equation, just substitute 4.44 f n2 phi m divided by 4.44 f n1 phi m for E1. Now when you simplify, 4.44 gets cancelled, f gets cancelled with denominator, and phi m gets cancelled. So you will end up with n2 divided by n1. So you know, according to the transformation ratio, E2 divided by E1 is equal to n2 divided by n1. That is what you are getting, which is equal to k. So till here you have to derive under EMF equation of a transformer.
Bible verse to meditate on.
Check out other videos in my channel regarding Basic Electrical and Diploma Mathematics 1. Please support this channel by subscribing to Joe Educare and click on the bell button to get the notification regarding new videos. Thank you. God bless you all. Bye.